Imagine a world right next door in our cosmic neighborhood that might have once been a twin to Earth. A world with vast oceans, a temperate climate, and maybe, just maybe, life. That world is Venus. But today, it's a scorching, toxic nightmare, with surface temperatures hot enough to melt lead and a crushing atmosphere of carbon dioxide. What happened? What catastrophic events turned our sister planet into a hellish inferno? Today, we're diving deep into the geological and atmospheric secrets of Venus, to uncover its fiery past, and see what lessons its transformation holds for us. Let's start our cosmic detective work. The biggest paradox of Venus is its current state versus tantalizing hints of a very different past. Scientists look at Venus today and see a wasteland, but the data tells a more complex story. There are clues that point to a history involving liquid water in a much more temperate climate. So how do we bridge the gap between a potential paradise and the furnace we see today? We have to dig into the planet itself. The surface of Venus offers some fascinating clues. We see vast volcanic plains, suggesting the planet has been resurfaced by lava flows. But there are also ancient, highly deformed highland regions called tesserae. Some scientists think these could be the remnants of ancient continents, similar to Earth's. Their unique composition and eroded appearance hint that they might have once interacted with liquid water. Then there's the atmospheric evidence, which is even more compelling. When we analyze the Venusian atmosphere, we find a surprisingly high concentration of deuterium, or heavy water. Deuterium is a heavier version of the hydrogen atom found in normal water. Since the lighter hydrogen escapes into space more easily, a high deuterium-to-hydrogen ratio suggests that Venus once had a lot more water that has since been lost. It's like finding the skeleton of a long-vanished ocean. So if Venus had water, where did it all go? The culprit seems to be a runaway greenhouse effect. Here's how it likely happened. Over billions of years, our sun has gradually been getting brighter and hotter. As Venus received more solar energy, its oceans would have started to evaporate, putting more water vapor, a powerful greenhouse gas, into the atmosphere. This trapped more heat, which caused more evaporation, creating a catastrophic feedback loop. This warming was supercharged by another factor: volcanoes. Venus appears to have experienced intense, planet-wide volcanism for an extended period. This massive volcanic activity would have pumped colossal amounts of carbon dioxide into the atmosphere. With CO2 levels rising, the greenhouse effect went into overdrive, boiling away the last of the oceans and locking the planet into an irreversible hothouse state. But wait, there's more. Unlike Earth, Venus lacks a strong global magnetic field. Our magnetic field acts like a shield, protecting our atmosphere from being stripped away by the solar wind. Without this shield, Venus's atmosphere was left exposed. As water vapor rose high into the atmosphere, solar radiation would have split the water molecules into hydrogen and oxygen. The light hydrogen atoms then easily escaped into space, lost forever. This process, combined with the runaway greenhouse effect, sealed Venus's fate. So what can we learn from our fiery twin? Venus is a stark cautionary tale. It shows us just how fragile a planet's habitability can be and demonstrates the catastrophic potential of a runaway greenhouse effect. It is a cosmic reminder of why understanding our own climate and taking care of our planet is so critical. The story isn't over, though. A new era of Venus exploration is dawning. Upcoming NASA missions like Da Vinci and Veritas, set to launch around the end of this decade, will give us our most detailed look at Venus yet. They will analyze its atmosphere and map its surface in unprecedented detail, helping us to finally confirm whether Venus truly was the first habitable world in our solar system. The lessons we learn from Venus won't just tell us about our past. They'll help us understand the potential for life on countless exoplanets across the galaxy. Thanks for joining us on this journey to our twisted sister planet. If you're fascinated by the mysteries of our solar system, be sure to like this video and subscribe for more cosmic explorations. See you next time.